asteroid or comet we had seen before. Oumuamua raced through our solar system with an unexpected shape, elongated, cigar-like, and no glowing tail. Even more puzzling, it accelerated away from the sun in a way that defied conventional comet or asteroid behavior. Was it a chunk of rock, a shard of ice, or something artificial? The debate still rages. Then, in 2019 came 2I Borisov, the first interstellar comet ever seen up close. Borisov seemed more familiar. It had a bright coma and a long tail, just like the comets that come from our own solar system. But its extreme speed, about 32 kilometers, and its hyperbolic path through space made clear that it too had originated beyond our sun's domain. And now, in 2025, a third visitor has arrived, and this one may be the most unsettling of all. Meet 3I Atlas, nicknamed 3I Atlas. This object stands apart, both in its sheer scale and in the strange, almost alien behavior it shows. Telescopes worldwide and in space have turned toward it, drawn by its mysteries. As they probe deeper, the more scientists realize this may not just be an interstellar comet, it may be a cosmic relic from the distant past of our galaxy. On the night of July 1st, 2025, a telescope operated by the Asteroid Terrestrial Impact Last Alert System, ATLAS survey in Chile, detected something unusual. Located about 4.5 astronomical units, AU, from the Sun, near Jupiter's orbit, the object moved unusually fast across the sky, and its trajectory didn't match any known asteroid or comet class. Within hours, observatories in Hawaii, Arizona, and Chile were pointed toward this phantom visitor. Initial images showed a faint halo of gas and dust, a subtle coma, and the beginnings of a short tail. Clear signs that this was an active comet, not a dormant rock. Digging into archival data revealed that the object had been inadvertently captured earlier, by ATLAS itself and by the Zwicky Transient Facility, ZTF, allowing astronomers to reconstruct a longer arc of its motion and thus compute its orbit with high precision. The results were staggering. 3I Atlas was not bound to the Sun. Its trajectory was wildly hyperbolic, with an eccentricity around 6.1 and a hyperbolic excess velocity measured at about 58 km. That's more than twice the speed of Oumuamua and significantly higher than Borisov. In late October, as it swings around the Sun, it is expected to peak at relative speeds of about 68 km, making it the fastest interstellar object ever observed. Such a velocity demands a long, chaotic history through interstellar space, shaped by gravitational encounters with stars, planets, or gas clouds. As the object approached the inner solar system, more revelations followed. On July 4th, the European Southern Observatory's Very Large Telescope, VLT, captured sequences of its motion across the starfield, and spectroscopic observations detected atomic nickel and cyanide gas in its coma, elements commonly found in solar system comets. This hints that interstellar comets may share chemical building blocks with comets in our own system, reinforcing the idea of a common chemistry across the galaxy. Next, the iconic Hubble Space Telescope locked in on 3I Atlas on July 21st, delivering the sharpest images to date. From this data, scientists estimated the nucleus could measure up to about 5.6 kilometers across, comparable to many standard comets within our system, and place its minimum mass at roughly 33 billion tons, making it by far the largest interstellar visitor we've ever tracked. But perhaps the most staggering discovery came from the James Webb Space Telescope on August 6th. At roughly 3 AU from the Sun, where water ice normally begins to sublimate, 3I Atlas instead showed a coma dominated by carbon dioxide, at a ratio of about 8:1 compared with water. That ratio is roughly 16 times higher than what is typically seen in solar system comets at similar distances. The implication? This object likely formed in a weird, frigid environment where carbon dioxide ice dominated over water ice. Why? Perhaps the star system where it formed blew away its water vapor early, leaving behind an outer region rich in CO2 ice. Or maybe 3I Atlas passed close to a star long ago, losing its water ice, or its water remains deeply buried beneath an insulating crust. Whatever the reason, The chemistry simply does not match what we know from our own comet population. And where did this relic originate? Scientists turn to the Gaia mission, which has measured the positions and motions of over 1 billion stars in the Milky Way. Using Gaia's data to rewind the comet's trajectory across 4.27 million years, astronomers identified 62 stars it may have passed by, but none with enough gravitational pull to strongly alter its path. That suggests the object didn't come from our immediate stellar neighborhood. Instead, the data point to the boundary between the Milky Way's thin and thick galactic disks, a transitional region home to ancient stars. If 3I Atlas did indeed originate here, it could be over 10 billion years old, twice the age of our Sun. In essence, this visitor might be a time capsule from the early Milky Way, carrying pristine frozen records from an ancient planetary system. So as 3I Atlas speeds away from the Sun and out of our solar system forever, it leaves more than dust and gas behind. It leaves questions, possibilities, and a deep sense of connection to a much larger cosmic story. From the unexpectedly strange behavior and chemistry, the extreme speed and hyperbolic orbit, to the implication that it might have formed in a wildly different planetary system billions of years ago, this third interstellar visitor has expanded our perspective. It reminds us that we are part of a galaxy teeming with wonders, and that sometimes the most profound discoveries arrive unannounced, speeding through our celestial neighborhood like ghostly messengers.